Good evening. My name is Guy Edward, and I'm here to talk about the brief history of computer development. Let's start with the introduction. Computers have developed from large size, simple machines, smaller, more powerful, and complex machines. The evolution of computers to the current state presented in terms of generations of computers. Each generation is designed based on a new technological development of the computer. Up to date, there are five computer generations. And let's start with the first generation of computers. The first generation of computers was designed in 1940 to 1956. First generation of computers used virtual cubes, the base component, memory, and circuit CPU. As you see here as an example of vacuum tube, was all glass inside the vacuum tube wires at the bottom here. This is what was used, the circuit CPU. The input, output, computers use punched card printouts respectively. The computers accepted the use of machine language, the input of instructions. The computers were very large in size, so they needed large rooms installation. The most famous first generation computer is the IAS. I'm going to talk about briefly some of the examples for the first generation computers included the HEDVAC, the EDSTAC, the UNIVAC, and many others. The IAS was developed by von Neumann and it used the structure. The whole point computer receive input would be instructions and data were passed to the MBR, which is the memory buffer register, stored the instructions or data temporarily. What is taken to the arithmetic logic circuit. The arithmetic logic kept performing arithmetic logic operation with the help of the SC, the data register, and the multiplier quotient register. So that the result taken back to the MBR, the stored result temporarily, before it is given out as output or stored in the memory. Also, the MBR, the memory buffer register, employed the other registers, which is the instruction register, program counter, and the memory address register to help it get instructions memory needed the processing of information. That's it for first generation of computers. Now let's go to the second generation computer. Second generation computers were developed from 1956 to 1960. They basically used transistors to replace the vacuum tubes. Vacuum tubes had disadvantages like burning, they were expensive. The transistors were cheaper, smaller, and more efficient. Also, second generation computers used cores, primary storage, and magnetic tape for secondary storage. They still relied on the use of punched cards, printouts for the input and output respectively. There was the introduction of high-level languages such as COBOL and Fortran that were used. An example of the IBM 700 is an example. The picture that shows the transistors. That's it. That generation of computers had this hallmark that development of the printed circuit were developed in 1964. They covered forward and reverse. The IC chips were used, which were used, contained multiple transistors placed on a silicon chip. Here there was a keyboard and a monitor, which were used as input and output respectively. The third generation of computers involved remote processing, time sharing, real-time programming, operating systems used. High-level languages are mostly used instead of machine language. The high-level language were easily understood by humans, which made the production as reduced greatly in size. Example are the IBM 360, the IBM 70, and the first generation of computers used microprocessors, thousands of compute per single silicon chip. Generations computers also saw the development of GUIs, the mouse and other devices. Icon, one example of graphical user interfaces that the computers became smaller, third generation of computers. Examples, there was the Macintosh computer, IBM 510. I want to show you an example of graphical user interface. For this graphic is a graphic interface where you can basically tap an image, get where you that was first generation. There's easy interaction. Okay, now let's talk about first generation, which is the computers or the computers that have them are based on the use of 20, 20 about voice recognition and interaction with machine learning, all these people and as user process that are make automated necessary. Examples include the Apple Mac M1. That's a brief history. Okay, now let's talk about the evolution, the Intel x86 and the ARM architecture. Okay, starting with the Intel x86. The Intel x86, the processor architecture that was introduced in the late 1970s and has undergone various developments and improvements since this time. The Intel x86 focuses on design complex instruction set computers. The evolution of the Intel x86 architecture has summarized can be summarized briefly as In the late 1970s, there was the introduction of x86 architecture, which is the Intel 8086 microprocessors. Introduced this 16-bit processor was the foundation which the x86. The 16-bit era was during the 1980s. Intel followed up with the 8186, 8286 processors, continuing the 16-bit architecture. The Intel 8286 introduced protected mode, paving the way for multitasking protection. 32-bit transition during the early 1990s. 8386 processor released in 1985 marked a significant shift, introduced 32-bit capabilities and virtual memory support, making it the first 32-bit CPU. In the 1990s, there was the Pentium 1, Pentium 2, Pentium 3, and Pentium also improved the performance and added new instructions. The Intel processors, the Intel x86 64-bit transmitters were introduced during the and this introduced the Intel Titanium processor 2001. However, it was the Intel 64 architecture EAM640 2004 that extended the processors to support 64-bit computing. AMD AM64 architecture. Multi-core era was during the multi-core processors became the norm, with Intel releasing its Core Duo and subsequent generations. These processors focus on embedded. During 2010s, there was Sandy Bridge that was introduced in 2011. Main purpose was improvement in integrated graphics and power efficiency. The recent developments up to date, Intel continued to release more micro Skylake, Kaby Lake, and however, landscape the AM Ryzen processors. Moving on to ARM architecture design, which is focused on instruction set computing, employed in a wide variety of tasks. Here's an overview of evolution of the ARM architecture, advanced virtual machine. The ARM1 introduced in 1985 was a 32-bit RISC machine design. It was initially developed by Acorn Computers. In 1986, there was the ARM2 processor that was supposed to improve the version of the ARM1. Led the introduction of extended instruction set and better performance. In 1991, there was the ARM6, which brought significant enhancements, including a 5-stage pipeline and support for caching, making it suitable for early handheld devices. The ARM7, which was introduced in 1993, an instruction architecture that helped better interrupt handle and improved performance, making it popular in embedded systems. ARM9 was introduced in 1997. ARM9 processors offered increased performance and support Java acceleration as better than 2000. ARM11. The ARM11 architecture featured higher clock speeds, various smartphones and embedded systems, which increased the speed of such devices. Moving on to the Cortex series, we had the Cortex A, Cortex R, and series that were between 2000 and present. Cortex S are major hits at W because of the high performance processors, while the R series focus time process common were used in the Cortex M series were designed for microcontroller applications, providing up low cost and efficient processing solutions. 64-bit ARM architecture was introduced in 2011, which was the ARM v8 meant with the Intel Server high performance processors like and 7. The Cortex A75 and A55 were in 2007. These processors are part of the ARM9 architecture, which offered and power efficiency mobile devices. Neovus architecture introduced Neovus data MX servers. The recent ARM architecture innovate architecture focusing energy efficient AI